If you've ever been curious about Go to build like really optimized, scalable, fast backend servers and applications, this is the perfect video for you. So in this video, we'll be going over the very basics of Go, so such as the data types, the syntax, what are structs, arrays, slices, what are dereferencing, pointers, etc. So this video will give you a very basic foundation to build further applications. So in the subsequent videos, we'll be building application using these concepts. So hopefully you all find value from this. I've got an empty VS Code running here. So we are inside the learn go YT folder. So in here we can create a new file called main.go. So this is where our code starts from, and at the top you'll have to import or something called package main, and then we'll have to call a function called function main. So this is where all our code runs from. So whenever you start a program, it starts from this function right here. So in here, let us print something to the console. So I'll print something called let's go with hello world itself. So you can see, yeah, I'll save it. So we're using a module called fmt, which will allow us to print stuff in our terminal. So you can still see I've got an error here. This is because don't have a mod file here, but we'll get rid of these squiggly lines very soon. So let me just run this file and just see whether everything works. So to run our main.go file, we can run this command called go run main.go, and if I hit enter, I should get hello world. Okay, so you can see I'm getting a squiggly line. That's because I have an extension here called go. So this will allow us to make our development process much more easier. It'll help us debug programs. It'll show all the errors and all. So I highly recommend it. So that's one of the extensions which you'll need, or rather, if you don't, it'll be more difficult for you to, like, while running the code, you'll get errors. So this will allow us to debug the program much more faster. Anyway, so now you can see we have the squiggly line. So to get rid of that, what we can do is we can initialize some go mod file by having this command called go mod init. So this github.com, so this is just the name. So I'll just say github.com tabish learn go, right? So I believe this is the standard way of naming things. So if your name was, say, Sal, it would be Sal / whatever your project name is. So you can see here we got our go mod file right here, and the squiggly line is also gone. So yeah, so let me again run the file. Cool. So we are getting hello world. So which means everything here works. So now let me show you how to initialize a variable in Go. So in Go we can do something like var and say message. We'll also have to give it a type called string, and then we can assign it a value called hello world, right? Then let me again print it out in the terminal. So fmt print, let's go with ln. So ln just means in a new line. It'll print it in a new line, and I can just run the program again. You can see hello world, right? So but this is a old way of doing things. The standard in Go is to use something called we can initialize and infer the type with just this in a very concise manner with a colon is equal to sign. So if I just delete this, you can see we get the same thing, hello world. So this right here, the colon is equal to sign, infers the type for us. So you can see the Go already knows what type it is. So if I say if it has true, it should give me a boolean value. Yeah, right here. If I give it a 5 and save it, you can see it's an int value. So I believe this operator is called the walrus operator. It's a funny name, but That's what it is called, the walrus operator. So this is how you initialize variables in Go. And there's another fascinating thing about Go is that if you declare a variable called message2 and you don't use it, you get this error from Go saying that this is not used. And if you try to run the program, then you'll be getting this error saying message2 declare and not used. So whenever you're declaring a variable, you should always use it. That's how Go works. And it also makes sense, right? If you're declaring a variable and not using it, why is it even there? So that helps us save space as well, so which allows us to optimize our code, and one of the reasons why Go is so fast. So that is one thing. So now we know how to declare variables. So now let us go to arrays and slices. So to create array, what we can do is I can say var numbers, and I can define the space and initialize it 5 int. And then what I can do is I can say numbers, say 0, and say, let's say 5. Now let me copy this, paste it 2, 3, 4, 5 more times, 4 more times, and I'll change this to the first, second, third, and fourth value. And I'll change this as well to 10, 15, and 20, 25, and I'll print this array here. So this is the standard array which we use in almost all programming languages. You can see 5, 10, 15, 20, 25. But there's another data type in Go called slices, which allows us to create arrays of dynamic sizes. So you don't have to mention the size of it, and you can create arrays. So right now I've created a numbers slice which is of the int type, and if I can put certain things to it. So I can say numbers append number 1, and if I hit save and run the program, I'll get 1. The same thing I can do 5 times. I can do like 2, 3, 4. So I can create any number of values here. So that is the benefit of using slices. It's dynamic in nature. You don't have to, it doesn't have a fixed size. So that is what that is one of the key differences between arrays and slices. Now another way of defining this would be something like this. So we can use the, let me actually undo all that, and let me create another slice. Let's say numbers 2, and I'll use the walrus operator. I'll define its type and say int, and I can give it some initial values 2, 3, 4, 5. Let me copy this, call it numbers2, and save it, and I'll run the file. So now you can see we have 2, 3, 4, 5 which we defined here, and we can also append values to this. So I can say numbers2 and give an equal to sign, say append numbers2, and let me put 6 here, and let's again print the numbers2. So if I save this, if I run the program, you can see we have 2, 3, 4, 5, 6. So that's basically how slices and arrays work. Arrays again have fixed values here, and slices are dynamic arrays basically. So you can you don't have to define the size for the slices. So now what we'll do is we'll go into loops. So in Go we can define loops in this manner. So this is pretty standard in most programming languages. So here we have not put in brackets, but so you initialize your iterator with the walrus operator, you give it a condition and you increment it, and if you save it, you should be getting the loop, which basically prints a new number in each of the lines. So this is how we do in most programming languages. But there's another thing in Go where you can infinitely loop over certain things. So for that we can use fmt print ln say numbers. So what this basically without a condition does is that it infinitely prints the array here. So now if I run the program, it should have given me an infinite number of the arrays, but it's not. That's because I haven't saved this file. So I'll save it, run the program again, and you can see it keeps on printing. So now I'll just terminate that. So that's basically how you create infinite loops in your Go program. So now let me show you a more realistic approach of how you would use this. So instead of printing the numbers, let me just get rid of all this and print let's say first segment, and then let me return this. So this return statement, basically what it does is returns out of the function. So if a certain condition is met and if you put the return keyword, it basically exits out of this main function and your program stops running. So now if I just to demonstrate this, if I have another statement here called second segment, and if I put here third segment, you can see what happens. So in this program, what would happen is this first segment would be printed out, and this return keyword would basically exit this function, basically terminating your code. Not terminating, exiting, finishing your code. So now if I run this main.go file, you can see we just have one first segment, like the first statement, which is first segment. So there's another keyword called break. So the difference between break and return is that break basically exits out of this for loop. You can see this is already giving me a squiggly line, but if I run the program now, you can see the first segment is printed out and this third segment is also printed out. This should have, I think, statement would have been a better name for this, but whatever, you get the point. So return exits out of the function and break just exits out of the loop. So that's basically the difference between return and break. So because we were dealing with loops, I thought for loops would make sense. But now let us go back to data structure, data types, and define a new type called maps. So basically maps are key value pairs, and if I print this out, so if I print it out to the console, ages, you can see, and I run the program, you can see this gives me a map of key value pairs. Now if you wanted to access one of its values, again it's simple. You give it a square bracket and mention which key it is, so Bob, and this will give you the value of this key. So now if I save this, run the program, and you can see it's 30. So let me show you something interesting now. So now if I have an if condition and give this as the condition, so what this basically means is whenever you give a condition to the map ages Alice, it returns two things. One is a value, and the other one is a boolean value, whether it is true or false. So now, and this basically after the semicolon, what this is the return type of this condition. So what this returns. So this is if this condition exists, if this key is there, then we'll get the ages value. And if I save this and run the program, you see it's 25. If I say let's say Carol and save it, it should be 35. What if I give something which does not exist? So now if I run the program, you get nothing, because the return type, if it's only true, only then this is printed out. So now what if you wanted to say add Eve? Let's say Eve. Let me just show you what happens. Again, this should not return me anything, but now if I under here, I can add Eve and give her an age, so it'll be 28, and I can say let's print this out. So let's say Eve's age is, and let me just give age Eve, and if I hit save, this should now print Eve's age is 28. So this only if this exists, because this does not exist, we don't print it. It's printing out the age only once. So when the code reaches this statement, Eve does not exist in the map, and after this finishes, we add Eve and we print it out. That's why we get only one statement. Next is let's look at how to delete certain elements from our map. So there's just a function called delete, and you give it the map and also the key to delete it. And if you save it, and now if I just print out the entirety of the map, so ages, you can see now we shouldn't be getting Eve. So let me print it out. So you can see when the code reaches here, we print Eve's age is 28, and once we've deleted it, there's only 3 values here. So now let us try looping over it. So while looping over it, it gives us 2 things, which is key value. Now let's put a walrus operator, and now let us look into something called range. So range is a very handy keyword where you can loop over the arrays, slices, channels, etc. So let me show how this works. So you give it the range and the array over which, or array or maps which it has to loop over to. So let me give ages, and then what I can do is I can just print it out. So let us use something new now. So print f, and now what printf basically does is allow us to print in something dynamically. So key, if you give a percentage sign s and comma value, I'll explain what this is shortly. So I'll give again a percentage sign and d, and let me also return it. So I think n, and you can give it key value. So if you've done Python before, you know what this is. So this basically percentage s basically puts a string value here, and percentage d puts a int or decimal value right here, and the dynamic values go here, key value. So now if I save this and hit run main.go, you can see we are looping over to each of the keys and values. So that's how this range keyword works. It basically loops over arrays, slices, etc. Yeah, so that's basically maps and how range keyword works. So next up is structs. So structs are basically similar to how objects are in JavaScript. You define a type called car and give it some attributes, brand, model, and also mention its type. So both of the brand and model of car object is of a string type. So I won't call it object anymore because we are not in JavaScript, we are in Go. So I'll call it as struct. So this struct has brand and model both of string type. Now to create a struct of car, what we can do is I can say my car, give the walrus operator, mention the type, so car, and then if I just hit brand, put Toyota, and I'll also give it the model, which is, let's say, Camry. And now if I was about to do console log, whatever, so fmt print ln my car, and if I run the program, you can see I have Toyota Camry, which is the struct. So that is how you create structs in Go, and this is very important because we'll be using this immensely in the upcoming videos. And now let me create another struct called let's say let's call it truck, and it's the same way. You can like create my truck, and I can say I'll give the walrus operator, give it the type, and give the values as well. So truck is of brand Ford, and if I hit my truck again, if I call it my truck, and it's giving me an error because we are not using this, so I'll comment this out. I can run and you can see Ford. So that is how we can create these structs. Now to manipulate these, what we can do is, I can just go my car dot model and I say Corolla, and if I print out my Corolla, I mean my car, we should be getting the model as Corolla. So that's how you can change values. It's very simple, very straightforward. But now let us go into something called interfaces. So this is how we create interfaces in Go. You just say type the name of the interface and give it the key interface, and you give it the functions in which it has to act on. So we use interfaces for some advanced programming techniques such as polymorphism. But let me just give you a gist of how this works. So in an interface, you give it all the functions which are to be used by your structs. So now say start, if we had stop, we could have said stop, but just to keep it simple, let me just give it a function called start, and let me create a function called start. So now let me say func, and in here I'll say C car. So this is basically the receiver or the thing in which this function should act on, and I'll call this function as start, and I hit open the bracket and say fmt print f, let's say starting. Okay, this works. So we say starting car.brand car.model. So again, this is the receiver, so this is on the structs which it should act on, and this is the function name. So now I'll do the same thing again for trucks. So instead of C, I'll say T, and here I'll give as truck. So this might be a little bit confusing in this at start, but as we build more complex projects throughout this series, you'll get to know it better. So we have t.brand and there's no model, so I won't mention anything here, and I hit save. Cool. Now let me uncomment this out. Now we can create a new array type. So let's say vehicle, and I'll give the walrus operator so that it automatically infers the type. I'll give it an array of vehicle and my car and my truck. So now what we can do is let us loop over this. So now we can loop over this. So I'll give the initial as dash v, and we use dash in Golang when we are not using certain things which are returned by whatever precedes this. So walrus operator range vehicle. So as we are not using the value of each of these vehicle, we don't need that. We just need the iterator. So this is the iterator. Now if I say, oh sorry, I flip those two. This is basically the iterator. So if I print, if I put I here, this will be the iterator and this will be the value. I confuse that. So v is basically again the value of each of the vehicle, and I can say v.start. So now if I hit save and run main.go, it says starting Toyota Camry, starting Ford. So that is the gist of what interface is. So it might come out as confusing in the beginning, but trust me, as we go along these videos, it will become much more clearer. So I'm getting something else here, so is missing. That is probably because here I'm mentioning we are getting two values here, but I'm giving only one. So if I just delete that out, save it, print it out again, you can see starting Toyota Camry, starting Ford. So again, interface is basically all the functions without its implementation mentioned here, and then you can implement this type for each of the structs. So say if instead of if I would have put start, and say I would have said stop and give it the stop function here, it would give me an error because both of these structs don't implement this function. That's why it's giving me an error. So that is how this interface works in Go, and we'll be exploring this in more detail later on. Now let us move on to one of the last concepts which will be done in this video, called the dereference operator and the address of operator. So now if I have an x variable, I'll give the walrus operator and give the value of 5, and now if I have this and sign and x, what this address of this is called something called as address of operator. This basically stores the address of x. So now if I just print this out, I'll print x out and I'll print y also out, and if I run this program, you can see I have 5 and code like output here. So that is this is basically the address. So this address of operator, I'll just call it and sign. This and sign gives us the address of x. So now if I just prefix x with and, this should give me the address of x. And if I save this and if I run this, you can see both x and y have the same address. So what we can do right now is, if I go down here and say y is equal star y, so now again this is something new again. So star is basically the dereference operator. This basically gives you the value of the address. So now if I say star y and hit and I say 10 and I can print out x. So if I print out x, you'll see what happens. And if I run the program, you can see in the beginning the x value was 5, and just by changing the y value with the star and assigning it the 10, we can change the x. This is because y stores the address of x, and whenever you change y, I mean if you prefix y with the dereference operator, it basically points us to x and allows us to access that value, or we can change the value. So now we are changing that value. So if I remove this and say, y star and I save this, run the program, you can see 5 5. That is how this address of operator and dereference operator works. So now let us just go a little further. Now let me create two functions here called change value by pointer and change value. So the only difference between these two are, this change value by pointer takes in a pointer int and this takes in a regular int, and we are changing the value here. Pointer initial num is equal to 5 and initial num is equal to 5, and we are returning those numbers. So now we can see what is the difference between this. So now let me initialize x as 4, and here what I can do is I'll say changed number is equal to, I'll first call in the change value and it takes in a number, so I'll put in x, and now let me print it out. So let me say print ln. So let's say original number, let me just say print f. This will be much more easier. So let me say original number, and let me give a %d, and let me also go to a new line and give it as num, right? Not num, this will be x, and the same thing, I'll copy this, say changed number, and here I'll give in the changed number, changed, I'll just copy this and paste it right here. Okay, this is because I have to give it the walrus operator. Now if I save this and run this, you can see the original number was 4, which is true, and when I change the number, I passed in x here, so x goes here, and we initialize x as 5 and return it, and the change number will be whatever x is. So you can see it's 5. So that is how a regular function would work. Now what we'll do is we'll change this function to change value by pointer, and it's giving me an error sign because this takes in a star int and we are just passing it x. So whenever it takes in a star, you'll have to pass in the address of that parameter. So here I'll just pass in the address of it, so and x, and if I save this now and I run the server, you can see the original number is 5 and the change number is also 5. So what this basically has done is, when we pass in that parameter here and change it to 5, this number as well gets changed. So this does not create a new instance for us, it changes the original instance. So that is the difference between sorry, it's not a difference, but that is how pointer and the and sign works. Now let us go even further with implementing structs. So in here I'll just remove these two functions and create something new here. So I have a person struct with name and age field. Again, I have two functions. One is modify person, it takes in the p struct and a person struct, and we change it to John Doe and age is 30. And this is modify person by pointer. So this takes in a pointer person struct, and again we change the name and age of it. So now let me again delete all this, and hopefully with this example you'll understand it better. In here I'll create a new person struct, I'll initialize it as an empty, and I'll say modify person 1. So I'm calling this the regular one. So this changes the name to John Doe and age to 30 of person 1, and I'll print it out. So I'm direct initialization, I'll give it the name s, age d, person 1 dot name, which should be John Doe, and person 1 dot age, which is 30. Right now if I run this, you get name as nothing, age as nothing. Now what if I do this with the pointer? So let me just copy all of this and let me paste in this here, and I'll say person 2. Again, we initialize with the person struct, and let's say modify person by pointer and say person 2, and this should be the address of it. Okay, this should be the address of it, or this would be better. So here, while initializing only, we'll give it the address of person, and we can say person 1 dot name, this should be person 2. Good thing I saw that. This should be person 2 dot name, person 2 dot age. Now if I save this and run the server, you can see the name is null, age is 0, but for modify person by pointer, we're getting the name and age. So we'll be using this a lot more, like we'll be passing in pointers, reference, dereference, and we can make changes to it. So the reason of this is basically because when we are passing in the person 1 to this function, it does not change the original one, it does not have access to it. But when we are for the second case, when we are passing it by pointer, we are giving it the address itself of the person struct to this person too. So whatever changes you're making inside this pointer will be reflected across all of your functions. So just consider you having, like, this is function main. If you have function, let's say child function, and you pass in these values by pointers to those function, make changes inside it, you'll be able to change the original as well. I know that is seems a lot, but trust me, in the upcoming videos it'll all be clear for you.